To entrance and beyond. So this is day 7 of my DSA series. Today I will be covering question number 904, that is fruits into baskets. So let's dive right into the question. So the question states, you are visiting a farm that has a single row of fruit trees arranged from left to right. The trees are represented by an integer array of fruits, where fruits of I is the type of fruit the ith tree produces. You want to collect as much fruit as possible, however, the owner has some strict rules that you must follow. You only have 2 baskets, and each basket can hold only a single type of fruit. There is no limit on the amount of fruit each basket can hold. Second property that we must follow is starting from any tree of your choice, you must pick exactly one fruit from every tree, including the start tree, while moving to the right. The picked fruits must fit in one of the baskets. And the last constraint, once you reach a tree with fruit that cannot fit in your baskets, you must stop. Given an integer array, fruits return the maximum number of fruits you can pick. Let's look at the test cases. So the first test case has fruits is equal to 1, 2, 1. So what does this mean? This basically means the 0th tree has fruit 1, the first tree has fruit 2, and the second tree has fruit number 1. So we can think about it that 1 maybe might represent a mango tree, and 2 might represent a orange. So we can say that the 0th tree has a mango. The first tree has an orange. The second tree has a mango. So output is 3, so it says we can pick from all 3 trees. Let's look at the second test case. So fruits is equal to 0, 1, 2, 2. Output is 3, and then the explanation states we can pick from trees 1 to 2. If we had started at the first tree, we would only pick from trees 0, 1. And the last test case, fruits is equal to 1, 2, 3, 2, 2. Output is 4. We can pick from trees 2, 3, 2. If we had started at the first tree, we would only pick from trees 1, 2. And over here, the constraints are given. So fruits.length goes from 1 all the way up to 10 to the power 5. And fruits of I can go from 0 all the way up to fruits.length minus 1. So let's dive right in. So I'll explain the question in a bit more detail, just in case you didn't get it. So it's simple. We're basically visiting a farm. There's a single row that has an n number of trees. We're basically going from the left to the right. And on each tree, there's a certain type of fruit that is represented by an integer. So like mentioned over here, fruits of I is the type of fruit that a tree produces, and we're basically using numbers to represent the type of fruit that a given tree is producing. Our goal is to pick the maximum amount of fruits while obeying some criteria. So we basically have 2 constraints that we will have to deal with in this question. The first constraint is that we'll have 2 baskets, and each basket can only hold fruits of the same type. They can hold an unlimited number of fruits, but the only problem is that each basket can only hold fruits of the same type. So we can say, for example, if we have a basket, it could hold only mangoes. Suppose mangoes are represented by 1. Then we could have a second basket that it can store only oranges, and suppose oranges is represented by 2. So this is the first condition, that each basket can only hold a unique sort of fruit. And the second constraint is that we're starting from any tree of our choice. We have to pick exactly one fruit from every tree, including the start tree, all the way up to the end tree. And basically, when are we going to stop? We can stop when we reach a tree where the fruit cannot fit in your basket. Then you must stop, and that is pretty much all that we have to do. So I'll show this using an example. So suppose we have 2 baskets. So this is basket 1, this is basket 2, and this is the input that we have currently. So this is basically currently the input that we have. So I'm just going to use white to show the fruits. So let's see. Basically, we're going to come up over here. I is 1. So as you can see, we have both baskets are empty. So we can basically add it to the first basket. And now what happens is the first basket can only contain fruits of type 1. Then we go to the next element 2. It cannot come in this basket because this basket is now occupied by fruit number 1. So we're going to add 2 over here. Now we encounter another one, and we're going to add 1 to this basket. So as you can see, our output is 3. We can basically pick from 3 trees, being 1, 2, 1. Now let's look at another case. Another case would be fruits is equal to 0, 1, 2, 2. So we're going to start off with 0. We can store 0 in the first basket, and then we can go to 1. We can store 1 in the second basket. And then 2 cannot be stored in either of the baskets because the first basket is reserved for fruit number 0, and the second basket is reserved for fruit number 1. So that means we have to stop right now. But the question states we can start from any tree, so that essentially means we have to look at all the subarrays. So now what we're going to do is we're going to start at 1. So 1 gets added to this, then we get a 2, 2 gets added to the second basket, now we get a 2, 2 gets added to the second basket. So as you can see, the maximum number of fruits that we picked would be equal to 3. Now let's look at the last case. We basically have 1, so 1 would be added over here. Then we go to 2, 2 would be added over here. 3 cannot be added anymore since there's no basket where 3 can be stored. So then we'll have to consider our new subarray. So let's say our new subarray is a subarray that starts off at 2. So 2 comes into this basket. Then we encounter 3, 3 goes into the second basket. Then we encounter 2, so 2 is going to go in the first basket again. And then we encounter another 2, so 2 goes in this basket. So as you can see, the answer is 4. So how did we say the answer is 4? The answer would basically be the number of elements in this basket plus the number of elements in this basket. So don't you think rather than actually maintaining 2 baskets, we could just have a map where we store the frequency of each of the elements? So we can see that the frequency of 2 over here is just 3. And the frequency of 3 over here is 1. So we can say that we basically ended up picking a total of 4 fruits. That is what we have done. We've ended up picking 4 fruits in total, and that is the result. So that is pretty much all that we have to do. So now let's think about it using our code, because now this was the approach, and you probably understood that we don't actually have to use 2 baskets to actually solve this question. We're going to do something else. So let's dive right into the code. So I think I'm going to take this example, and I'm going to show you how things work out. So since we are dealing with subarrays, something that's probably clear to you now is that we can use a sliding window sort of approach. And the logic is simple. In each window, we can have at most 2 unique elements, and we just have to count the maximum value that you can get by storing 2 unique elements. So we can basically say our sliding window would help us do this. It would help us determine the 2 unique elements that are to be stored, and then we can basically go on and end up solving this question. So that is pretty much all that we plan to do. So I'm going to take this array, and now I'm going to take 2 pointers. So the first pointer will be our left pointer, and the second pointer that I'm going to take will be our right pointer. So we're going to start off with 2 pointers, and what we're going to do is we're going to store a variable, and the variable's name is going to be count. So count basically represents the number of baskets or number of unique elements thus far. That is pretty much it. So it's going to be 0 initially. And we're also going to have a map that will be used to store the frequency of each of the elements. Because we saw in the previous case, we could just sum it up and then we'd get the maximum sum. So we sort of need the map just to take care of the deletion part. So that would probably, or the part where we shrink our window. To take care for that, we are going to use a frequency map. So what we're going to do is we're going to start off over here. Whenever we get a unique element, what we're going to end up doing is we are basically going to end up incrementing count, because that would mean we need an additional basket. So that is pretty much all that we're going to do. So there's going to be 2 main conditions. If the count is less than or equal to 2, we can basically move ahead, add new fruits from different trees. And once the count exceeds 2, we must basically shrink our window, where we will try to basically start off at a different point. So I would basically traverse through this, and hopefully this does give you an idea about the solution. And if you feel confident about the solution already, you can try it yourself, and then you could come back to this video and complete it. So let's dive right in. So what's going to happen, we can see count is equal to 0. So since count is equal to 0, we can add the new element. So what we're going to do is we are going to add the right element. So the count basically becomes 1 because this is in fact a unique element. And how do we know it's a unique element? We can say it's unique because in the map initially we can think that the frequency of 1 is 0. So since the frequency of 1 is 0, it means we have encountered our first unique element. We're going to increment count, and now the frequency of 1 becomes 1, and now we can move ahead. So we move R ahead. Now we check count is less than or equal to 2, correct? So that means we can still use R, or we can still expand in short. And now we come to 2. So essentially what would happen is 2 already has a frequency of 0 just in the initial state. 2 has a frequency of 0 in the initial state, and count is less than 2. So what we're going to do is we're first going to increase the frequency of 2 to 1, and now count becomes 2 since it is a unique element. So now what we can do is now we can move R ahead, And what we're going to do is we're going to keep on computing maximum. So maximum is basically r minus l plus 1. So as you can see over here, index 0, index 1, index 2. So 2 minus 0 plus 1, that would be the size of the window, number of elements. So that is perfectly fine. Now since count is basically, now what we can do is we can add 3. Now you can see that the frequency of 3 is basically 0. So the frequency of 3 is essentially 0. We check that out. And count is less than or equal to 3, equal to 2. So what we're going to do is we're going to increment this. Now count becomes 3. So when count becomes 3, that means that this element is not going to be added in our window. So now we're going to start a while loop and actually begin shrinking. So when we're shrinking, what are we going to do? So something simple. Count would only decrement once the frequency of a given element becomes 0. Then at that point we can say count decreases because we're not considering that tree anymore. So now what we're going to do is we're going to start off with left. That is what we're going to do. We're going to start off with left, and we're basically going to move it ahead. So what we're going to do is first we're going to decrement this, the frequency of this element. So frequency of left is first going to get decremented. So that would basically convert this to 0, and since this becomes 0, we can say that count becomes 2 now, and we are going to consider, we're going to then move r ahead. We're going to move left ahead to basically shrink our window, and now we're going to compute the new length. Now this point of time everything's perfect, so now we can increment, we can move r ahead. So what's going to happen is we're going to take this r and move it ahead. Now count remains 2 because this is not a new element, it's already present. We're just going to increase its frequency. Then we're again going to move this r. I'm going to take this r and move it ahead 1 position again. I'm going to take this r and move it ahead 1 position again. And again, this is not a unique element, so the frequency basically becomes 3. And on each step, we're basically computing the maximum length. So our answer would basically become right minus left. So that's basically 1 minus 4 plus 1. So that's basically 4, and 4 is the output as expected. So this was basically a dry run. So now let's code it up. So like I mentioned, we're going to have 3 main variables. Into left is going to be 0, right is going to be 0, and then we're going to have a variable count that stores the number of unique elements. And we are going to take an unordered map, int comma int, and then which is going to store the frequency of the element. Now it's simple. We're going to use a while loop. So while or right is less than fruits dot size. What are we going to do? So first we're going to check if count is less than or equal to 2. In this case, what are we going to do? So first of all, we are going to check initially if frequency of fruits of r, if that is already equal to 0, we must increment our count first. Simple, count goes ahead, and then we're going to increment fruit of r itself. We're going to increment its frequency. So this is all in the if statement, and then we can run a while loop. So as I mentioned, we're basically moving ahead till this condition is not met, right? So we can say while count is greater than 2, we can say we have to shrink. So we could do it one step at a time, but I don't think it's really useful, so we could just run it at once. It wouldn't really change the time complexity because at the end of the day, we're still traversing through fruits once, so it doesn't make a big difference, and it's slightly more intuitive if it makes sense to you. So now we're going to check if frequency of fruits, simple. We can we can first check. So if frequency of fruits dot left, if that is equal to 1, we can do count minus minus, because once we subtract it, we know it's going to become 0 anyway, so we're doing it just prior hand in short. And then frequency of fruits of left minus minus, and that is pretty much it. We've got to increment left, and then right's going to get incremented all the time. But before incrementing, we basically need max length. So we're going to have another main variable max length, which will basically store our answer. We want to initialize it to 0. So max length is equal to max of max length, comma right minus left plus 1. Like I mentioned, r plus plus. And now we simply have to return max length, and they should work perfectly fine. So we basically took left, right, count, max length. We took an unordered map, frequency. We basically go through fruits while the count is less than or equal to 2, we check if it's 0, count plus plus, then we're incrementing the frequency of roots of r. When count becomes greater than 2, which basically means that we have to shrink now. We're going to check if frequency of roots of left if it is equal to 1. We're going to do count minus minus because now the frequency is going to become 0, so we can decrease the count. And frequency of roots of L minus minus, we're going to increment L, we compute the maximum value, we increase R, and then we just basically return max length, which is supposed to be our answer. So as you can see, this works perfectly fine. And the approach basically took big O of n time. And again, space would also become big O of n in short. Or yeah, that's pretty much it. So thank you for tuning in. Hopefully you did this question did make sense. And please give me feedback, so you can DM me on my Instagram page for Entrance and Beyond. You can send out a comment on YouTube, or you can directly reach to me on LinkedIn. So no issues with that. But this was day 7, and hopefully things actually have started to make a bit sense to you, and you're actually improving as a coder. So see you tomorrow then, and thank you so much for tuning in.